Hello everyone, hope you all are doing well. So now we will start our next topic, that is hydrogen spectrum. So today we will discuss hydrogen spectrum just diagrammatically. Okay, so let's move further. Actually, a hydrogen spectrum is the fingerprint of, you can say, elements, molecules or atoms. We are taking the fingerprints of that. But how we know that, how we are taking that? So we are taking that with a hydrogen spectrum. So move toward hydrogen spectrum. For that we will take a discharge tube, that is also called the Crookes tube. So let's suppose that this is a discharge tube, or you can say Crookes tube, and it's attached with a battery. Okay, it's attached with a battery, and this one we are having in different amount of hydrogen. Okay, we are having hydrogens over here. What we will do, that this battery produce electrical discharge, that discharge break down these hydrogens into the number of molecules, and after that the sun rays just heat these molecules and produce different series. So now we will discuss about that series that sun ray produce with the different rays. So that is also happening in this one discharge tube, but we will, for your easiness, I will making it more easy. Just wait. Okay, so talking about that, let's suppose here we are having one graph, just not a graph. Okay, now what happened, that as I told you, that hydrogen just break down in different positions. Hydrogen 1 2 3 4 and 5. These are the 5 types of hydrogen. These are the infinite, but we are just taking the 5. After that, what happens, that here we are having shells. Let's suppose just we are having shells. This is, we are having K shell, this is L shell, this is M, then N, then O, and then P, and then infinite position over here. Okay, so we are just taking some of them: K, L, M, N, O, and P. K, L, M, N, O, P. Okay, now what happens, that let's suppose this is the sun. These sun rays produce which one rays? Ultraviolet rays, visible rays, infrared. These ultraviolet is invisible, this visible will be visible to us, infrared is also invisible. But in infrared we are having 3 types of rays. One is near infrared, okay, NIR. Second, we are having mid infrared, MIR, and we are having far away infrared, FIR. Okay, so let's talk about this. When these heat up to these molecules is hydrogen, so which series produce for the spectrum? So just let's move further. Okay, so these I have written the name of infrared, that is ultraviolet, visible, near infrared, mid infrared, and far away infrared. Now what happens when ultraviolet ray just heats up to the hydrogen molecules? This hydrogen molecule, what this hydrogen molecule do? Just let me select another color. What this hydrogen molecule do, that it's moving from the its K position to the infinity position. Like now we are having P. Okay, it's unstable over here because of high energy. But when at one position it's lose its energy, means to low down its energy, so it's coming downward. How? Like from O position it's come to K. Just wait, it's not making that much perfect. Like from O to K, then from N to K, N will also join to K, M will also join to K, and L will also join to K. Okay, so at this one K position it will be stable. Okay, so now what we will write over here, we will write here one thing that I want to tell you again, that N 2 power 2. Now N 2 power 2 means, like on this position it was unstable. Okay, on which position? Like on second one, means on this one second one, on third one, then we have fourth, then we are having fifth. Okay, and sixth also. But it was only stable on which one position? First position. Which one? Just first position. So N 2 power 2 means the total number of orbits on which it was unstable. So we will write here 2, 3, 4, 5, 6, and if infinite, so infinite over here. But now there is one more thing, that is N 1 power 2. N 1 power 2 means on which position it got stable. So it got stable on first orbit, that is K shell. So we have to write this series like this. Okay, so let's move further. Hope you understand this one. Let's move to the next point. Now we will come on the visible ray. On visible ray, what happened? We can take another color for your understanding. Now don't think so I am taking these colors just for the understanding, not this color represent any thing. I am just taking for the understanding, that you can understand easily that how it happened. Again, now visible ray is on L position. From L position to infinite position it was unstable over here. Okay, after that, if from O to L it was again unstable. Just wait, let me show you. Unstable, then from N to L again unstable, then from M to L again unstable. Means it was unstable from which position? From second, not from second, from third, fourth, fifth, and sixth orbit it was unstable. But on the second orbit, the visible ray, or you can say the electron of that, loses its energy and is stable on which one? Second one orbit, that is L shell, as I told that how we will write that mathematically. After that, move to next. Now we are having near infrared rays. In near infrared rays, it started from M position. Like from M position it moves and it unstable over there. So from you can say from N to M it's again unstable. From O to M it's again unstable. Now from which position it was just stable? On which one position? On third position, on M shell. But N, O and P, these shell was unstable. So we will write that third, fourth, or not fourth, fourth, fifth and sixth unstable orbits, and third is its stable orbit. Okay, now let's move further. I don't have more colors. No, I have. Okay, so now we are having mid infrared. Mid infrared, what it does, that it start from the fourth one, that is N. Like from here it was unstable here, and what it did, then it's come, it was unstable on O also and P also, but is stable on the N. So we will write that fifth and sixth was unstable orbits of mid infrared, but the fourth one is a stable orbit. After that, move to last. Okay, now we will take the far away infrared rays. Now far away infrared, like it's not till the p position, it was infinite, means till infinity, that how much orbit it is. It not depend on us, it's infinite orbits, but I am just giving you an imaginary example that we are taking till p points. After that, this one on this one orbit. Okay, now when we heat up, the electron got unstable, got more energy, it moves there. Okay, but again it come back with p position, means it will go from its O to P, and it got stable from P to remain stable on its position, means firstly move it, then lose its energy, and also come again on its position. So now these series have a name. Scientists have given this series a name, and the name of this series, wait, let me write. Now I will write the name of this series that you have to remember. Ultraviolet rays. This series is called Lyman Spectral series, or you can also say Lyman series. Which one series? Lyman series. Like, yeah. So it's called Lyman series. First one series is called Lyman series. Talking about second one series is called Bohr series. Visible, right? This series is called Bohr series. After that, move to third one. Third one is called Passion series. This is called, wait, it's not working. This is called Passion series. After that, move to next. Mid one infrared is called Bracket series. It's called Bracket series. And last, means not last, if there are the more infrared rays, it's called P fund series. But in our syllabus till here, we just know this. In inter, we will know more about this. These are the name of the series. Now I will just do one more thing for you guys, that now we have made a graph of this series. Now what we will do, we will make the orbit of the series. As I told you, it will be in the p orbit and l orbit, n orbit. So I will make the orbit. Okay, now let's make me orbit. Okay, so we are making the orbits. Oh, just wait. First orbit means the last one, p1, that we understand. Just wait. After that, another that we are having m, not m, p, o. We are having another. Then we are n. Then we are having m. Then we are having l. Then we are having k. Then this is our nucleus. Okay, now let's understand that how we have put it over here. As I told you, first one series called Lyman series. Okay, now this is our first point. This is our k shell. Let me also write the names. Just wait. K, L, M, N, O, and P. Okay, and this is our nucleus. Now what we will do, that as I told you, first one is a Lyman series. So Lyman series start from the K position. This is a K position. It got unstable over here. So what it does, so on the O position it's coming to be stable to K. From N it's coming to be stable, then from M it's coming to be stable, from L it's coming to be stable. Okay, but it's got stable from all the position. We got tried to got stable, but it's got stable on the K position. Okay, because it's low, previously heating up and having high energy, it move upward, then lost energy, it comes downward. So this is a Lyman series. After talking about Bohr series, means Bohr series electron is in L position. This is the L position. From L position we heat it up over here, electron. Okay, this electron heat up, after that it's come down like now it got stable on the L position. This is called Bohr series. After move to Paston series. Paston series, electron is in K, L, M, in M1. So in M1 what we'll do, it got here excited and high energy level. After for low it moves downward, mean that 2 it goes. Okay, now after that we are having bracket series. In bracket series we are having done with K, L, M. Now we are having N position. For N position it will got started from here. Okay, for N position it goes from here and it got here. After that it loses energy from one position to another. It's also get stable in N position. Okay, after that I think I did something wrong. K, L, M, N, O, P. First one is in K, second one is L, third is N. Sorry, by the way, now I told about bracket series. This is a Lyman series, first one. This is our we are having Bohr series. This is Paston series. This is bracket. Now last we are having P-Fund series. P-Fund series come in last one line, means it moves upward from here, then it's come down to stable over here. So these are the series that we have understood today, that how it got stable with the hydrogen spectrum. Now these orbits work like these are the very fine thin lines these are. So we can finding a hydrogen spectrum means the fingerprint of our elements, molecules, atoms, and it's also used in other things like x-rays, all the things like we are seeing that how they can wash. So they are very thin and fine lines that they are finding with this one spectrum. So hope you understand today's lecture. Thank you so much for listening.